Our research looks at how sourcing tools like electronic reverse auctions can be designed or adopted to include operational and strategic considerations in outsourcing manufacturing. Now, electronic reverse auctions or reverse auctions have long been recognized as a tool for reducing input costs, for instance, by buying from the lowest bid supplier. However, in doing so, a buyer might become too over-reliant on this single supplier, and therefore it might want to procure from multiple suppliers, a strategy that's often referred to as multi-sourcing or diversification. Now, multi-sourcing has other benefits too. For example, maintaining health of the supply base. Now, firms establish guidelines, it's often referred to as sourcing rules, such that its procurement managers consider multi-sourcing actively in procurement. An example of such a sourcing rule is, say, a firm might establish a cap on the maximum allocation or order size that a procurement manager can give to a particular supplier. Now, how can procurement managers include these sourcing rules into their reverse auction? Well, one straightforward way of doing this is by organizing what's referred to as split award auctions. In a split award auction, the procurement manager would announce upfront, that is, before the auction, its splits. For instance, it would announce that it will procure X% of its business from the lowest bid supplier, Y% from the second lowest bid supplier, and so on, such that these allocations, X%, Y%, and so on, follow the sourcing rules or are constrained by these sourcing rules. Now, in a recent work with Damien Bile at University of Michigan and Elena Katok at University of Texas, Dallas, we'll look at such split award auctions in terms of how suppliers will bid in these split award auctions and how should the buyer design these split award auctions in terms of what should be the optimal splits that a buyer should announce such that these splits satisfy the sourcing rules or sourcing constraints. To give you an example of the type of problem we consider here, think about the following sourcing rule. A buyer establishes a cap of 60%, which is the maximum amount of business that this buyer or its procurement manager can source from any single supplier. Now, given this 60% cap, should a procurement manager split its business greedily? Now, by a greedy split, we mean that the procurement manager would allocate the maximum possible business such that it satisfies the sourcing rule sequentially starting from the lowest bidder onwards. So if the cap is at 60%, a greedy split would involve or would mean that the sourcing manager announces a 60-40 split. That is, it procures 60% business from the lowest bidder and 40% business from the second lowest bidder. And obviously it announces the split before the auction. Now, in such a greedy split, the buyer would lessen the competition amongst the two lowest bidders. The reason being that being the lowest bidder only gives you slightly more business than being the second lowest bidder, because second lowest bidder gets 40% and the lowest gets 60%. An alternate split, which I will refer to as non-greedy split, could be a 60-20-20 split, whereby buyer announces that it will buy 60% from the lowest bidder, 20% from the second lowest bidder, and 20% from the third lowest bidder. Now, in this non-greedy split, there would be more intense competition between the two lowest cost bidders, because now being the lowest cost bidder gives you substantially more than being the second lowest cost bidder. However, the buyer encourages this competition at a cost to itself, which is buying some business from the third lowest cost bidder. Now, the question for the buyer is, should it announce greedy split or a non-greedy split? And if it's non-greedy, then what should be the optimal split? Using auction theory, we characterize a buyer's expected cost for a given split that it will announce. This expected cost obviously considers the supplier's equilibrium bids that they will submit in such an auction. And once we have characterized this cost, we can find out what should be the optimal split that the buyer should announce. Interestingly, what we find is that a buyer's choice between announcing a greedy split versus a non-greedy split depends upon the underlying distribution of supplier's cost. What we find is that if supplier's underlying cost distribution is regular, examples of regular distribution include unimodal distributions whose density function is log concave, like normal distribution, uniform, exponential. So if this underlying distribution is regular, then a buyer should optimally split in a greedy manner. However, if this underlying cost distribution is non-regular, for example, it's multimodal, in that case, a buyer might find it optimal to split non-greedily. What that means is that under certain situations, a buyer might reduce its input costs, purchase costs, by diversifying more than what's strictly necessitated by the sourcing rules. We take these theoretical predictions and test them in controlled economic experiments using human subjects. And we find that these theoretical predictions hold true in these experiments. So interestingly, what we are saying is, or a managerially relevant finding of this research is, that a buyer's cost reduction and diversification goals could be aligned. Or in other words, if a buyer has to diversify, which is in case of these sourcing rules, then it might actually reduce its procurement cost or its purchase cost by diversifying more. Thank you.